Hi everyone, the topic we are going to discuss today is deadlock detection bankers algorithm. In theory part, we have already covered what is a deadlock and what is the reason for occurrence of deadlock and what will be the situation when the deadlock has occurred. In today's session, we are going to see an example problem for solving under deadlock detection bankers algorithm. In this, the inputs given for the problem are the total number of process P0 to P4 along with its allocated instances. That is, the process P0 to P4 is already allocated with few instances of resources, and for completion of its task it needs the maximum number of resources which is given on the next column of the input, and the total instances of the three resources are given. In this, A resource has total of 10 instances and B resource has total of 5 instances and C resource has total of 7 instances. In this problem, the available is already given. In case if the available of resources is not given, the formula which is used for finding the available matrix is that available equal to total instance minus allocated instance. The total instance of the resources are, there are three resources A, B and C. The total is A has 10 instance, B has 5 and C has 7 instance. For finding the allocated instance, we have to find the sum of allocated matrix from P0 to P4. For A instance, P0 is allocated with 0, P1 is allocated with 2 instances, P2 is allocated with 3, P3 is allocated with 2. So it is of totally 7 instance which was allocated for A resources. For by finding the allocated resource of B, it is 1 plus 0 plus 0 plus 1 plus 0, it is of 2. For finding the total allocation of C, it is 0 plus 0 plus 2 plus 1 plus 2, it is of 5. So we have to subtract this allocation from the total instance, that is 7 to 5. While subtraction, 10 minus 7 it is 3, 5 minus 2 it is 3, 7 minus 5 it is 2. So this is the available number of resources. This is already given here. If it is already given in the problem, that's not an issue. If it is not given in the problem, these are the steps to be followed for finding the available resources. After finding these available resources, next thing we are going to find is that we have to find the need matrix. Okay, that is nothing but, for need matrix we have to, the formula we are using is the maximum resource minus its allocated resource. That is the formula for finding the need matrix. So we are using that formula here. In this, for the process P1, the maximum is 753 minus its allocation 0, 1, 0. That is 7 minus 0, 7, 5 minus 1, 4, 3 minus 0, 3. So 743 is the need for P0. Likewise, we have to find for P1 to P4. It is 322 minus 200. It is 1, 2, 2. Then for P2, 902 minus 302, it is 600. Then for process P3, 222 minus 211, it is 0, 1, 1. Then for process P4, 433 minus 002, it is of 4, 3, 1. this is the need matrix for the given process. This is given in the next slide. This is the need matrix. After finding the need matrix, for allocating the resources, the first we have to check is that whether the need is less than or equal to available. Only if the need is less than available, when the resources are available, then only we can allocate it for the process, right? So we have to check it whether the need is less than available. That need is here represented as request, right? If it is less than available, then we have to follow these 3 steps. If we follow this, then the process will complete its execution. That is, when the need is less than available, we will be allocating this available resources to the request, right? So it is given as available equal to available minus request. After subtraction, we will be allocating to that process. After allocation of that resources, the process will complete its execution. That is given as allocation equal to allocation plus request. Then after processing this, need equal to need minus request. Since the request is served, we are reducing the values from the need matrix. That's it. If we follow these 3 steps, the problem will be solved under Banker's algorithm. Let's see, this is another slide. Okay, this is our given example process from P0 to P4. From that, these are the allocation resources, and this is the need matrix which we have find, and these are the available resources. In this, the first step we have to find is that we have to check whether need is less than available. In this, the need of process P0 is 743. Whether it is less than available? No, right? So P0 can't be allocated with the resources initially. So we are checking for the process P1. P1's need is 322. Available is 332. So it is less than available. Since, check here, 332 is less than 322, right? So since this is satisfied, P1 will be allocated with the resource request of 322. After execution of this process, the already allocated resource will be freed, right, after execution. So the already allocated data will be added to the available. Available equal to available plus allocation. Available plus allocation. While doing this, 332 plus 200, it is of 532. Since P1 has completed its execution, we are noting it down for finding the safe sequence of this process. So P1 has completed its execution. After that, we will be checking whether the need of P2 is less than available. Current available is 532. Need of P2 is 902. Since it is not less than, we are moving for process P3. P3's need is 222. 222 is less than 532. So we will be processing for P3. After allocation of the need resources to the P3, P3 will complete its process, and the already holded data 211 will be freed. After that, 211 will be added to the already available data. 532 plus 211, it is of 743. This is the current available data. Since P3 has completed, we are writing it down in the safe sequence. After that, we will be checking whether the need of P4 is less than available. Need of P4 is 433. 433 is less than 743. So P4 can be allocated with that resource. After completion, 022 will be freed. So it is added to the available. The current available data will be of 745. Okay. Next, we will we will be checking for process P0 and P2 since these two are still pending and the resources are not allocated. After that we will be checking for P0. Now P0 has the need of 743. 743 is less than 745 which is currently available. So now we can allocate for process P0. After allocation of the resource, the already holded resource of 010 will be freed. So 010 will be added to the available data. Now the current available data will be of, what is the value? 745 plus 7010, it is of 755. So we will be checking for P2 whether this P2's needed matrix is, sorry, it is not 902. I think the need of P2 is 600. Yeah, it is of 600. Sorry for this error. It is of 600. Okay. In this, while we are checking whether 600 is less than available 755, yeah, it is obviously less than 755. So the resources will be allocated. After freeing of those resources, the already allocated data 302 will be added to the available. So 755 plus 302, it is of 1057. After completion of all these process, all those resources which was holded will be released. And for checking the concurrency of the problem, after completion of all the process, the total available should be equal to the total instance of the problem. Here the total available is 10, 5 and 7. In this problem initially it was given as 10, 5 and 7. By this we are saying this problem has completed and it is correct. We can check the concurrency with this step. Okay. After execution, while executing each and every process, we will be tracking the sequence of execution of the process. So finally, if we execute and allocate the resources for these 5 processes in the order of P1, P3, P4, P2, P0, we can avoid the occurrence of deadlock and the system will be in safe. This is the steps for solving the problem under Banker's algorithm. Thank you.